Okay, so we're going to look at the average mass of an element in Chapter 2, Section 7. Before I do, let's think about what we mean by that. The average mass of an element. So let's go back to Table 2.1, I think it was, Table 2.1, and think about the average mass of these particular particles. I wouldn't say average because all protons weigh about 1.00727. Can you see that from where you're sitting? Wait just a second here. Let me go back. I lost my color here. Let's go to red. Protons weigh about 1 AMU, right? And neutrons weigh about 1 AMU. And can you see that if I'm adding an electron to these two, it's negligible, right? So when we think about the average mass of an element, you really should be thinking about how many protons and neutrons it has. So one example we've used a couple times now is carbon. Carbon 12, carbon 13, and carbon 14. So how many nuclear particles does carbon 12 have? Well, it's got 6 protons, right? And if it's got 12 total protons plus neutrons, it must have 6 neutrons as well. And so the mass of carbon 12, if you look at it from this table, is really very close to 1, or rather 12 AMU. Can you see that? If you add up those, 6 times that, plus 6 times that, plus 6 times that, 12 AMU. What about the mass of carbon 13? That's going to be about 13 AMU, right? You can see why that would be called the mass number. Now, it turns out that the average mass of carbon is not 12 plus 13 divided by 2. Average mass is not 12 plus 13 divided by 2, right? It would be if it was half, if it was 50-50, right? So if you only had the average of, say, only 2 particles might be 12 plus 13 divided by 2. But in nature, we've got a bunch of them, right? Moles. Billions of billions of billions. So how do we calculate the average mass of an element? That's the problem. Well, here's the solution. What we do is we say that the average mass, or the atomic weight, is going to equal the sum of each of these, the fraction of isotope N times the mass of isotope N. So in the example that I was using earlier, we might say that carbon, let's see, carbon, and this is a sum right here, right? So carbon 12 is about 99%. 99% times 12 plus 1% times 13. And that is going to be the atomic weight. Okay, of carbon, roughly, right? Because carbon 12 in nature is about, like I just said that, 99% carbon 12, it's 1% carbon 13, and that's what this sum means, okay? So this is the fraction of carbon 12. This is the mass of carbon 12. Okay, here's the fraction of carbon 13, and here's the mass of carbon 13, and this is a summation. Right, so that's how this is going to be calculated. So let's consider this. The average mass of bromine, let me give you a couple examples here, is 79.904. That does not mean that the mass of a particular atom is 79.904. It's just the average. Taking all the bromine atoms together, it's going to be 79.904 grams per mole. Okay? Now, any one particular bromine is going to have, this is not a superscript up here, by the way. That's the atomic number. Any one particular bromine is going to be bromine 35. Rather, that's not true. Yeah, it's all going to be 35 because it's got 35 protons. But some of bromine has, you're not going to like this, 79 nuclear particles, and some has 81 nuclear particles. What? How would you know that? You wouldn't. We looked at it in nature and we simply wrote it down. There's no way you would know that, okay? So I think you're probably getting used to kicking the habit of simply doubling the protons and saying there's the same number of neutrons as protons. How many neutrons are in this? How many neutrons in bromine 79? Okay, it's going to be 79, which is protons plus neutrons, minus the protons, which is going to be, oh gosh, I can't do that in my head. Oh, is that 44? I can't do that in my head. So either way, subtract that from that. I think that's 44. Yeah, 79. There's 44 neutrons. Really? Wow. Why? Well, we don't know. That's outside the scope of this course. I mean, somebody knows, but we don't know. All right, so the mass of bromine 79 would be about 79. The mass of bromine 81 would be about 81, but the mass on average is 79.904. Okay, I'm not going to go through all that with chlorine, but let's look at this. Chlorine has two isotopes that are common in nature. One of them is chlorine 35, and the other is chlorine 37, believe it or not. And again, I'm going to say, well, how would you know that? You wouldn't. You would have to be told that, right? You look it up in a book. So the average mass, though, is 35.453. All right, there's a clever problem we could do with that, but let's think of a simpler problem first. Let's go here and say that copper has two naturally occurring isotopes. And let me remind you that the formula of this equation is the sum of the fraction of the isotope times the mass of isotope. And we might say, let's go different color. Just a second here, color black. Let's say we're going to sum this over n, the fraction of isotope n times the mass of isotope n. Okay, so we're going to use the same. Let's stick with black. Let's stick with black. My wife's calling me. Excuse me just a second here. Hello? Hi, honey. Listen, I'm recording a video right now, okay? Love you. Bye-bye. That is my daughter using my wife's cell phone. Okay, so copper has two naturally occurring isotopes. So we're going to do, first of all, the fraction of isotope 1, and that would be 0.629296, right? Because that's what a percent is, times, oh, that's not the fraction, that's the AMU. Bad start. Let's say that the fraction of the first isotope is 69%, right? So it's 0.6917 times 62.9296 plus the other fraction, which is 0.3083 times 4.9278. Okay, so let's do this in our calculators. 0.6917 times 62.9296 plus 0.3083 times 64.9278. Did I get those numbers right? 9278, 9296. Yeah. So it looks like the average mass is 63.545645. 63.5456. 63.545645 AMU. Calculate the atomic mass. Now let's think about sig figs for a second. There was 4 sig figs here, right? There's more than that here. 4 sig figs here and more than that here. So it looks like we're going to be at 4 sig figs. So this is going to be reported as 63.55. Okay. Tempted to look this up real quickly. Let's go back to periodic table. $63.55. All right.